So we have a 4 kg block A put on a rough inclined plane of 30 degrees. It connects freely to a hanging mass of 1 kg block B. Okay, so when the objects are released from rest, we find the block A are going to slide down the inclined plane, whereby there is a friction force of 6 Newton act on the block A. So we understood the motions is down the inclined plane, so the friction force should be acting upward along the inclined plane, and this friction force will be 6 Newton. We want to find for the accelerations of the objects and the tension in the cable. So the accelerations for the both objects will be the same because they are attached together by a string. So the tension on both sides of the pulley also will be the same, right? So we want to find for A and T. So FPD for block B, whereby for block B is attached with the string. So along the string we have the tension, and then block B have mass, so there will be weight acting downwards. Same go for block A, so block A is put on an inclined plane, inclined at 30 degrees. So along the string we have tension, and since the block A is slide down, so there will be a friction acting upwards. So the friction is given 6 Newton. Block A is put on the surface, in contact with surface, so perpendicular from the surface, we are going to have the normal force. And block A have mass, so there will be weight acting straight downwards. So refer to this right triangle. So here is 30 degree, here will be 60 degree, so here will be 30 degree. Okay, so we track along the inclined plane as x-axis, perpendicular to inclined plane as our y-axis. So the weight which act at an angle 30 degree. So we can resolve into component y and also component x. So the y component will be WA cos 30, and the x component along the inclined plane will be WA sin 30. So this is what I get after I resolving all the forces into each perpendicular component. Then I can start to apply the Newton's second law to solve the questions. So refer back to the figure given, refer to the questions. Block A is accelerate down along the inclined planes, and for block B is accelerate downwards. So refer to the FPD for block A. I write down the Newton's law, summation Fy equal to ma. So for block B, the weight is in the directions of A, tension is opposite to the directions of A. So we have WB minus tension equal to ma. So the weight of block B will be the mass of block B, 1 kg multiplied 9.81, minus tension equal to 1 multiplied A. So I have two unknowns, so I rearrange the equations. I'll get A plus T. But I cannot solve the question because we have two unknown, acceleration and tension. So I put it as equation 1. FPD for block A. So for block A is accelerate along the inclined plane. So we focus on the component of forces along the inclined plane which contribute to the accelerations of the block. So we have this one. The tension and the WA sin 30 is in the directions of accelerations, whereas FK is in opposite directions of accelerations. So we apply Newton's second law, summation of force along the inclined plane x directions equal to ma. We're going to have tension plus weight A sin 30 minus 6 Newton equal to ma. So I'm going to have T plus mass is 4 kg, G is 9.81, sine 30 minus 6 equal to 4a. Solve it, I will have 13.62 will be 4a. T shift to the right side become negative t, so this will be my second equation. So I already have two equations, so I will going to solve the equations simultaneously using mode equations in my calculator. So mode equations, then I'm going to treat a as my first unknown x, my second unknown t will be y. So for equation 1, the numbers in front, the first unknown is 1, then second unknown is 1, and the value of c is 9.81. Then for the second equations, the numbers in front of first unknown is 4, then numbers in front the second unknown is negative 1, then the numbers of c will be 13.62. So I'll get my first unknown, the accelerations will be 4.686. So I note it down, a will be 4.686 meter per second squared. Then the second unknown tension is y. The value is 5.124. So the tension will be 5.124 Newton. Then I get the answer for both questions.